Good morning, Professor, distinguished guests, and class. Today I will be discussing the use of robotics in Homeland Security. Let me begin by discussing the issue. In Homeland Security, there are too many facets to be able to constantly be monitoring, patrolling, and training for the next big event. With nearly 2,000 miles between the United States and Mexico, 5,525 between Canada and the United States, there is simply too much border to patrol and monitor without the use of UAVs, UASs, as well as UGVs. Furthermore, there is almost 12,500 miles of coastline, not including the Great Lakes, that needs to be monitored. This, much like Border Patrol, is not only expensive, but taxing on time and resources of the agencies that are required to monitor these coastlines. In order to alleviate the strain of the coastline patrols, the Department of Homeland Security has adopted an underwater surveillance technology, the robot tuna, or more commonly known as the bioswimmer. Developed in Massachusetts by the Boston Engineering Corporation, the goal is to use this technology to explore flooded areas of ships, inspecting oil tankers, or patrolling U.S. harbors to watch out for suspicious activity. Robots also provide an incredible asset when it comes to dangerous situations such as disaster response, search and rescue, radiological surveying, and SWAT operations. These are the robots that provide specialized values to the members of the Department of Homeland Security. In regards to disaster response, there have been numerous advances to unmanned ground vehicles that can provide very specific tasks and capabilities that assist in saving lives after a natural or man-made disaster. This includes UAGs that can carry people and equipment, as well as vehicles that can be outfitted to be controlled remotely.
The kit for outfitting a Bobcat for remote control use takes roughly 15 minutes to set up, and the machine can return to manned operation with the flick of a switch. With their heavy lifting capacity, the Bobcats could move rubble caused by explosions.
Please take a moment to look at this picture and imagine being a first responder trying to climb into one of these small holes to see if somebody's there. As you have just seen, robotics have the capability to provide heavy lift operations in areas that may be contaminated and unsuitable for personnel to enter. Another benefit of the robots in regard to disaster response is the capability to use smaller robots to enter areas where a human cannot. An example of this is the snake, which has the function to be controlled through tight rubble to perform search and rescue for survivors without wasting extensive amount of time digging through the rubble. The Federal Emergency Management Agency requested from the Department of Homeland Security's Science and Technology Directorate for the development of response robot performance standards. The DHS teamed up, and I quote, with the National Institute of Standards and Technology to develop comprehensive standards related to the development, testing, and certification of effective technologies for urban search and rescue robotics. These USR robotics performance standards cover sensing, mobility, navigation, planning, integration, and operator control in order to ensure that robots can meet operational requirements under the extremely challenging conditions that rescuers are faced with, including long endurance missions. In January of 2011, the Test and Evaluation and Standards Division, Science and Technology Directorate of the Department of Homeland Security, alongside the NIST Office of Law Enforcement Standards, published the standard test methods for response robots. Using the standard test method development cycle, they were able to create and develop a process for the best methods for testing the robots, resulting in the test and evaluation of these 8 robots for use during urban search and rescue missions. When it comes to UGVs being used for radiological surveying or in hazardous material situations in contaminated environments, there are several excellent functions that are provided. These functions allow for the operators to be outside of the contaminated or dangerous area while still having the capability to see what is happening in these contained areas. With the capabilities of these robots, they are able to identify what the contaminant is or the degree of radiation exposure at specific points. Furthermore, the UGVs are able to use the robotic arms to shut down switches, close contamination control doors, plug leaks, and overpack broken chemical containers.
The sensors that are on board allows hazmat teams to go into unknown areas with unknown contamination and establish and whether the levels are safe for personnel to enter.
UGVs are also capable of being equipped to hold equipment such as fire hoses, enabling firefighters to be well out of range of contaminated areas or high-intensity fires.